Good morning, class. We are looking at Chapter 2, Equations and Inequalities, Section 2.3, Models and Applications. Here's the second portion of it, Part 2, for college algebra. So we have looked at a lot of applications, and we are going to look at more examples. That's really the bottom line that we are going to do. Find measures of angles in a triangle if one angle is twice the smallest angle, and the third one is 20 degrees greater than the smallest angle. First, we have to define our variables. We're going to call the angles A, B, C, and you're going to decide which one is the smallest one. And it really makes no difference, but when you decide, you can make up all those equations. Let's say C is the smallest one. So first and foremost, when you have a triangle, the total interior angle must be 180 degrees. So without reading anything else, the fact that it's a triangle, they add up to 180 degrees. So that's the first equation. Now, the one in blue, one angle is twice the smallest one. Whatever. You can say A is 2C, or you can say B is 2C. It makes no difference, it's your choice. The third one is 20 degrees greater than the smallest one. Now, because we used B here, the third one is A. A is 20 degrees greater than the smallest one, C plus 20. And now, this is the translation. As long as we can go from the question to formulas, we are set. So, simply put, replace the B with 2C. I mean, it's a simple case of a substitution. So we're going to replace the B with 2C. We're going to replace the A with C plus 20, and everything is a function of C. So A is replaced with C plus 20, and B replaced with 2C. And now when we add them up, this would be 4C. We're going to subtract 20 degrees from both sides. We get 160. Divide by 4. C becomes 40. So if C is 40, what is B? 2 times 40. 80 degrees. What is A? C plus 20. So 40 and 20, 60 degrees. And of course, the way you check it, the sum must be 180. The sum must be 180. It's very straightforward, everybody. Find measures of angles if angle A and B are supplementary angles, and angle A is 30 degrees greater than angle B. First and foremost, what do we mean by supplementary? That's a definition from geometry. Two angles are considered supplementary if they add up to 180 degrees. So that's the first thing. Let's say those are A and B, or X and Y. This means this. Supplementary means okay. So again, maybe this is A, this is B. This is not to scale. They just add up to 180 degrees. That's the concept of a supplementary. Now let's go with the second sentence. A is 30 degrees greater than B. A is B plus 30. Again, substitution. Replace the A with B plus 30. Again, I remind you, you have access to all of this. Just sit back, relax, and make sure you're learning the concept. Is to add up to 2B. Move the 30 becomes negative on the other side. And with 180 becomes 105. 150, my apologies. Divide by 2 and you get 75 degrees. So if this is 75 degrees, the other one is 30 degrees more, 105 degrees. Do they add up to 180? This is how you check it again. 75, I'm using the second one, adding 30 and I get 105. Now I check with the first one, I add them up to I get 180. So the beauty of math is you can check your work and you must. You can check your work and you must. I can't emphasize this enough, okay? We have a similar situation. We want to find measures of angles if angle A and B are complementary and angle A is 4 times the size of angle B. So again, definition of a complementary is they add up to 90 degrees. Two angles are considered complementary if they add up to 90 degrees. So let's say this is A, this is B. Again, this is not to scale, class, just to give you an idea. Now, the second one in blue, it says A equals 4 times the size of angle B, 4B. Very simple case of a substitution. Again, replace the A with 4B. We get 5B. Divide both sides by 5. B is 18 degrees and A is 72 degrees. Why is that? You do it two ways. 4 times 18 is 72? Yes. Add them up. Do we get 90 degrees? Yes. Or simply put, if this is 18, the other one is 90 minus that 72 is 72 4 times 18. No matter what, you have to check with both equations to be on the safe side. Anybody wants to read this question for us, please?
I will.
Please.
Katie is paid $4.50 per hour plus 15% of the total cost of the food and beverages she serves during a shift at her restaurant. For a 4-hour shift, Katie receives $258. What is the total cost of the food she served?
Excellent. These are cases that you may have seen, or you may know someone who's been paid that way in a place. In essence, you can think of it as, a percentage as a commission and so forth. So what is the total cost? I don't know. How about X, Y, Z, any variable of your choice, everybody? Any variable of your choice. So we let it be X. And how much are we going to get paid over the course of 4 hours? If they pay us $4.50 per hour, we multiply these two plus 15% or 0.15 times X. So one more time. There's a 4-hour shift, $4.50 per hour. So the product of these two we get paid. 15% of the total cost, the product of these two, 0.15 and X, we get paid. Add them up. How much is it supposed to be? 258. So I hope it's clear to everybody. It's very straightforward, and you're going to move on. So all you have to do, multiply these two, move it to the other side. Four times 4, 16. 4 times half is 2, 18. You're moving it to the other side. That means we change the sign, subtract. On the other side, we get 240. We divide both sides by 0.15, which means if I change this to 15, then 240, let me use a different color. I need to add 2 zeros and I get $1,600, meaning if the total cost was $1,600, then the total pay would be $258 to Kate. Okay. Travelers crossing the GWB, George Washington Bridge, can either pay $1.25 cash or pay $1 using a pass system that is prepaid and uses a portable transponder that costs 25 bucks. How many trips over the bridge does it take for the two plans to break even? Break even, everybody knows, means they become equal. Break even, the same. First and foremost, we have to define some variable. So what do? We let X represent the number of trips over the bridge. You can choose N or any other variable of your choice. So if we want to pay $1.25 cash, that means over the amount of X number of times, we pay at 125 times X if we are paying cash. So if we pay cash and we use the bridge X times 125, end of the story. What if we want to use the transponder? We're gonna pay 1 times X and there is this fee of 25 bucks. So there's a fee to use that, 25 bucks. And then each time is $1. So 1 times X. So 25 plus 1 times X. We want to know when they will break even. When will they break even? And that's really the key. To break even, we set the two equal. That's the meaning of breaking even. So when we set them equal, one times X means X minus X, so it's 0.25 X equals 25 divided by 0.25. You may see this easily, it's 100, or you can say this is 25, this is 25, and I'm going to use a different color to emphasize I use 2 zeros here. The answer is 100. Now, it is extremely important to understand the meaning of this, okay? Besides solving the question. So if we use it 100 times, it doesn't matter which way we go. We go with the pay cash as you go, or we have a transponder and take it from. If we go less than 100 times, this is a better deal. But if we go more than 100 times, this is a better deal. And that's what you want to consider. So larger than 100, this is a better deal. The reason it becomes a better deal because it's only $1 after the 25 bucks, $1 each. It's less than 100, and you're sure you want to go with that deal. Could somebody read this question, please? Okay. I appreciate if you want to participate. There are
I'll read,
57
Professor.
sources. Yes, go ahead, please.
There are 57 sources of pollen: grass G, weed W, and trees T. If the number of weeds is 5 less than twice the number of grasses, and the number of trees is 2 more than twice the number of grasses, how many of each pollen source is there?
Excellent, thanks. I appreciate that. First and foremost, we look at the very first sentence. It says there are 57 sources. That means, and I call them GWT. You can go X, Y, Z. But when you go with the initials, it makes it easier sometimes, especially if you have more than 2 variables. Add them up, you should get 57. So G and W and T, their sum is 57. That's the first equation. The one in red says number of weeds is, that means W equals what? 5 less than twice the number of grasses. Twice the number of grasses means 2G. 5 less than that means 2G minus 5. So take a look at the sentence in red, everybody, sentence in red. W is 2G minus 5. W is 2G minus 5. Now let's go with the one in blue. Number of trees is, so T equals, this means equality. 2 more, 2 plus, and what? Twice the number of grasses. So 2G plus 2 or 2 plus 2G, either way is fine. And the most important part is to be able to make up these 3 equations. One more time. We have 57 sources of pollen. G, W, and T, add them up. 57. Number of weeds is W equals 5 less than twice the number of grasses, 2G minus 5. Number of trees is T equals 2 more, 2 plus, twice the number of grasses, 2G, in any order. And notice everything is a function of G. So in this original equation, the first one, all we have to do, replace the W with 2G minus 5 and T with 2G plus 2. If we do that, we end up with the equation that we are looking for, and we can easily solve that. It's pretty straightforward, everybody. And we are going to do that. So we keep the G, we change the W. To 2G minus 5. And T to 2G plus 2. And it's now pretty straightforward as to what's going on, right? All right, so what do we get here? G and 2G and 2G is 5G, and then negative 5 and positive 2 is negative 3. Move this to the other side, becomes positive 3, and therefore 60. Divide by 5, and therefore 12. So everybody, G is 12. So we found G to be 12. So let's go here. 2 times that, 24. Minus 5, 19. So W is 19. What about this one? 2 times 12, 24. Plus 2, 26. So we have all of it. And we can add them up. And we add up 12 and 19 and 26. And we do get 57. So the sum must always work. And it does. Okay, it's pretty straightforward, everybody. Okay, anybody want to read this one? I mean, I appreciate that if you can do that. You don't have to, but I'm sure you're tired of my voice.
Okay, I can read it.
Thanks.
The perimeter of a shed is a shape of a triangle of 60 feet. Find its dimension of one side of a 4 feet greater than twice the length of a smaller side. And the third side is 4 feet less than 3 times the length of the smallest side.
Excellent. So what do we need to know here? Okay, always define your variables. So the sides are X, Y, Z, A, B, C, whatever. That's your choice. We got to decide that C is the smallest one, everybody. So the perimeter is 60. Add them up. A plus B plus C is 60. So the first one, 60 means add them up. A and B and C, add them up. And that's what you get. Again, I want to make sure we understand sentence by sentence. Okay. Now, one side is 4 feet greater than twice the length of the smallest one. One side, let's say A, it doesn't matter which one, let's say A, is a 4 plus 2 times, we decided C is the smallest one. So 2C plus 4 or 4 plus 2C. The third side, well, obviously the third side here, it means B, right, everybody? The third side means B. The third side is B equals what? 4 feet, less than 3 times the length of the smallest one. 3 times the C, and then it's 4 feet less. That means 3 times C minus 4. That's the translation of the blue one. I put them in different color on purpose, so I want you to see how I go by sentence translating. Now again, A and B are both function of C, so replace the A with 2C plus 4 and B with 3C minus 4, and practically you're done. So that's what we get. And again, I want to make sure we see that A is 2C plus 4. B is 3C minus 4. And that's how we did the replacement. So it becomes clear as to what's going on. and we can easily move on. Let's put them together. They add up to 6c. These two cancel each other. Divide by 6. C becomes 10. And if I put the 10 into here, okay, 20, 2 times 10 is 20, plus 4 is 24. If I put it in here, 3 times 10 is 30, minus 4 is 26. So the animation wasn't in the order that I expected. But of course, the last one is to add them up, and it must add up to 60. 10 and 24 and 26, they do add up to 60. Again, pretty straightforward. All right, the amount of fencing needed for the illustrated rectangular area is 114 meters. Each rectangle has the same dimensions, with the length to be 1 meter longer than its width. Along the river, find the length and width of each rectangle. Okay, first and foremost, what they're referring to, there are 1, 2, 3 of those. Each one has a width that is the same, and the length which is the same, but it's 1 more than the width. So let's go with fencing means perimeter. So what do we have here? I want to make sure that we understand here. We have 1, 2, 3, 4 of them. That's the length. And the width, 1 and 2. And then there are 3 of them. 3 times 2, 6. So 6W plus 4L. Let me just write this next to it. Is equal to this. I want to show you that one more time. So here's the width. 1 and 2, 3 and 4, 5 and 6. Here's the length. 1, 2, 3, 4. That's the amount of fencing. Okay. Of course, we have this equation. I just mentioned that equation. So we have those. Very straightforward. So one more time. The length to be 1 meter longer than the width. That's this equation. And fencing means add them up. 6W plus 4. So clearly we change the L to W plus 1. So this is a substitution again. We distribute the 4 and we get 4W plus 4. We add the like terms, we get 10W, and we move the 4, subtract from the other side, we get 110. just drop a 0 from both sides or divide by 10 means W is 11 and the length is 1 more, so 12 meters. Very straightforward, everybody. I hope everybody is comfortable with this. And of course, you can check with this equation, 6 times W, which is 66, 4 times L, which is 48. They do add up to 114 meters. You should check your work, and you can always do that. And that's the beauty of math. You can check your work. Motion problem. A motion problem is one in which an object is moving at a specified rate for a specified period of time. When the amount in the formula is distance, we refer to the formula as the distance formula. So amount is rate times time. Most of the time we deal with a distance or a motion problem. So distance is rate times d equals RT. What I want to add here, class, a couple of things. Number one, the concept is very simple. You're doing 50 miles per hour on the average. Over the course of 2 hours, you cover 2 times 50, 100 miles. So if D equals RT, you should know R is D over T, T is D over R. In other words, if I give this number 1, 2, and 3, it's a given. 1, 2, 3 in essence are equivalent, okay? We should know that, and we use them from time to time. How long will it take a vehicle traveling 72 kilometers per hour to go 36 kilometers? I just mentioned that concept, okay? So T equals D over R is equal to D over T. In this case, what is missing is T, D over R. 72 over 36. Everybody knows it's half an hour. Pay attention to the units, everybody. Pay attention to the units. And be consistent. How about how fast in miles per hour must you travel to go 600 miles in 15 hours? D over T. 600 divided by 15. 60 divided by 15 is 4, so 40 miles per hour. Again, just to get us started, very straightforward questions. Anybody feels like reading this for us, please?
I will.
Thanks.
An aircraft carrier and a submarine from the same spot at the same time heading from the same destination. The aircraft carriers travel at 34 miles per hour and the submarine travels at 20 miles per hour. The aircraft carrier and submarine are to travel at this speed until they are 105 miles apart. How long will it take for the aircraft carrier and submarine to be 105 miles apart?
Excellent. Thank you so much. Let's see how we tackle that, everybody. we have to have this type of a table when we solve motion problem. So R TD, R times T is D. So the product of these two distance. Aircraft carrier, submarine, and let's plug in the information we get here. So that's the first thing we want to do. Okay. So let's go back and reread. The aircraft is doing 34 miles per hour. So the rate or speed for the aircraft is 34 miles per hour. Okay. And the submarine, 20 miles per hour. Okay. So the question is, how long will it take for the aircraft carrier and submarine to be 105 miles apart? We are looking for a missing time, and the time is the same for both of them. So you can say X, Y, Z, T, that's your choice. So the amount of time we don't know, we call it T. What is the distance covered by aircraft? 34T. What is the distance covered by the submarine? 20T. Okay. So 34T, 20T. I think I'll show it. So in here goes 34T, in here goes 20T. And their difference is 105. So 14T is 105 divided by 14. So the animation sadly wasn't in the order that I wanted. Now it takes 7.5 hours for them to cover 105 miles in two different directions. Okay, they be apart 105 miles. And so one way to check it, just multiply 7.5 by 34 and then by 20, and their difference must be 105. 105 miles, and you can check that. I'm surprised the animation wasn't proper, the speed of the animation. So this actually should come at the end. But in any event, 14T becomes 105 divided by 14, and T is 7.5 hours, of course. Okay. 7.5 hours. Okay, let's see. John leaves work at 9 a.m. and drives west on the freeway at an average speed of 50 miles per hour. Joe, his colleague, leaves work at 9:30 a.m. and drives west on the freeway at an average speed of 60 miles per hour. At what time will Joe overtake John, and how many miles will they each have gone? So both of them start from the same point. Okay. And both of them go in the same direction. but one of them starts at 9, one of them starts at 9:30. So here's the table. John starts at 9 a.m., Joe starts at 9:30, rate, time, distance. They have different speeds, different timing, okay? So what is the rate for John? John is doing on the average 50 miles per hour. What about Joe? Joe is doing 60 miles per hour. So those are their speed. At what time will Joe overtake John? So first, let's figure out how long it takes to get there. And so because we are interested in the timing for Joe, we let the timing for Joe be T or X or Y or Z or any variable of your choice. What would be the time for John? Well, if Joe is traveling for this amount, T hours, and John left at 9 a.m. versus Joe at 9:30, then the timing for John must be T plus 1/2 because we're going to go with the hours. The reason we're going to go with the hours because these two class are MPH, miles per hour. That's why we're going to go with the hours. And so the distance covered here is 50 times T plus 1/2, and over here is 60, okay, 60 times T, okay? So 50 times T plus 1/2, that's the distance covered by John, and 60T, that's the distance covered by Joe. Because we are interested to see at what time will Joe overtake, that means when will he reach him, in essence, we set the two equal. So again, the table, and then the equation, the rest is elementary algebra. So this is 50T, this is 25. We are going to subtract and we get 10T is 25. Divide by 10. And T becomes 2.5. And so far we are okay. Let's just go and answer a couple of questions. First and foremost, the question says, at what time will Joe overtake John? So we haven't answered the question. We found T equals 2.5. And then here's the Joe's time at 9:30. 2.5 hours later, 9:30 and 2.5 is 12 p.m. That's the first thing. The next thing, and they didn't ask, but just I want to add, what distance it took them to be having an equal distance? It's simply 60 times 2.5 is 150 miles. In fact, to check, if you want to check to make sure you haven't made a mistake, 2.5 is T, this is what? 3 hours. So let me just write in front of it. So this is 2.5. Therefore, this is 3. And the product of 3 and 50 must be the same as product of 2.5 and 60, the distance. This, in fact, proves everything we have done is right because we just checked it in essence. Okay, so that's really important to see what happened. Okay, everyone. All right, the concept known as a mixture problem is the product of strength and quantity equals the amount. Any problem where two or more quantities are combined to produce a different quantity, or where a single quantity is separated into 2 or more different quantities may be considered a mixture problem. Here's an example. In an event, 650 tickets are sold for a total of $4,375. Adult tickets cost $750 and children's tickets cost $350. How many of each kind of ticket are sold? We are going to set up this type of table. Okay. Normally we have a solution here, and this is not a solution class, okay? But rather people or age, you can say whatever you like. So definitely not a solution here, okay? So we are separating people by age, adults, children, and total cost of ticket for them, number of tickets, total value of tickets, okay? So the very first thing is that this is 650 tickets are sold. So how many tickets? 650 total. What is the cost for adults? 750, children 350. How much did we collect? 4,375. So 650 tickets total, 4,375 total collection of money. 750 is the cost for adults. 350 is the cost for children. How many of each kind? We put X to represent one of them, and it doesn't matter which one. For example, X represents the number of adults. This is the concept of a mixture problem. If the total is 650, then 650 minus X must be the number for children. So again, pay attention to the table, make sure every number is in the right place, and X, it's your choice which one is X, okay? I chose adults, but just be careful and keep track of what you're choosing. So this is 650 minus X. That's the first thing we should recognize. How much do we collect from the adults? The product of these two, 7.5 times X is collected from the adults. 3.5 times 650 minus X is collected from the children. And when we add these two, we get the total of $4,375. So everything that was mentioned here was put into this table in order to get us this equation. Now that we got this equation, practically we're done. We're going to distribute this to 3.5 times 650 and then 3.5 minus X. We get 7.5X, the product of these two, 2,275 minus 3.5X, and the right side doesn't change. We are going to combine like terms as follows. These two will give us 4X minus 2275. We are going to subtract 2,275 from the right side. So the left side becomes 4X and the right side becomes 2100. divide by 4, and we get 525 for X, which represents the number of adults. The rest of them, meaning 650 minus that, meaning 125 is the number of children. We are done. However, it's really a good practice to check as follows. If I multiply these two numbers, and if I multiply these two numbers and add them up, I must get the total amount of money we collected. So 7.5 times 525 plus 3.5 times 125 must be 4,375. And it is. You really have to check, everybody. I can't emphasize this enough, and I hope everybody is following that. Okay, so you definitely check your work to make sure that we haven't made a mistake. Okay, so we're going to move on to the next. Anybody wants to read this for us, please?
I can read it if you want.
Please.
Al needs a 5% oil solution to cure poison ivy. He only has oil solution that have concentration of 3% and 10%. How many milliliters of 10% solution must be mixed with 5 milliliters of 3% solution to create the desired 5% oil solution?
Perfect. So we have a mixture problem again. Now we have different solutions. Let's call them number 1 and 2 and the mixture. You can get rid of this column and just write the strength here. We're going to discuss that. And then the volume and the actual or pure amount. Now, this pure amount could be the pure amount of oil in this case, or acid or base. The concept is the same. Now, so what do we have? We need 5%, which we don't have. So what do we have available? 3%, 0.03, 10%, 0.10. You can write in a form of a percentage. But we need a mixture that results in a 5% strength. So 3% and 10%. These are the given, and the mixture is what's needed. We do not have it. So that's, in essence, the first couple of sentences. Now, how many liters of 10% do we need to mix with 5 milliliters of 3%? So we know 3%, then it's 5. So we have 5 here, everybody. 10%, we don't know anything about it. So that's X. Mixture problem, they add up to 5 plus X. And so what is the actual amount? If something is 3%, that means 3% of it is the pure amount of that material, acid, base, oil, you name it. So the pure or actual amount for this one is 0.03 times 5 here. This one is 0.1 times X, and this one is 0.05 times 5 plus X. Okay, so that's the concept, everybody. Okay, so 0.03 times 5, 0.10 times x, and 0.05 times the sum of 5 and x. Well, you can dilute things, you can change their concentration, but the actual amount can't change. Therefore, this last column says these two that are being mixed, add them up, and we get to the last. And so now, let's finish the job. This is 0.15, 0.1x or 0.10x, doesn't matter, 0.25, 0.05x. So distribute. We are going to move this to this side. Okay, so I'm going to move this to this side, becomes minus 0.05x, and we are going to move this one to this side, becomes minus 0.15. These two add up to 0.05x. These two add up to 0.10. And if I divide by 0.05, I hope you recognize it becomes 2 or just 10 over 5. And so how much do we need? Two milliliters of 10% solution to add it. So the question was, again, I want to make sure we understand. We have 3% and 10%, but we want a 5%. And we're going to use 5 milliliters of 3%. Okay. How much of 10% do we need? We need 2 milliliters to come up with the answer, which of course will result in 7 milliliters of what we need, 5% solution. Okay. One thing I want you to know, the mixture, the strength must be always between these two numbers. Okay. Must always be between these two numbers. Also, you may notice 0.05 is closer to 0.03 times 0.1. Therefore, we need more of that. See, this is 5, this is 2. And these are some basic information as far as this is the concept that I want to discuss, okay? Kevin is Tom's father. Kevin is 35 years old. 3 years ago, Kevin was 4 times as old as his son was then. How old is Tom now? Again, if we want to solve this problem, we have to set up an equation, a table as follows, in my opinion. So Kevin is the father, Tom, current age 3 years ago. So let's see what we know. Currently, Kevin is 35. How old is Tom currently? We have no idea. X, Y, Z, T, your choice. So we're going to say Kevin is 35 and Tom is T. 3 years ago, Kevin must have been 32, right? 35 minus 3 is 32. Tom must have been T minus 3. Now let's write an equation for this. So 3 years ago, Kevin was, so 3 years ago, 32 equals, in essence, 4 times as old as his son. So 4 times t minus 3. So I hope you see this translates to this equation from this column. So this is 4t minus 12. So 44 is 4t. Divide by 4, and we get 11. I think it's pretty straightforward. I hope everybody's okay with that. Now, you can, of course, check to make sure everything is correct, as you know, checking is really the key for mathematical questions. So t is 11, and (11 minus 3 is 8). 8 times 4 is 32. So it makes sense. Perfect sense. Okay. Lisa is 16 years younger than Kathy. If the sum of their ages is 30, how old is Lisa? Well, let's say Lisa, her age is X, then Kathy would be the same thing plus 16, X plus 16, right? Add them up. That's the meaning of this sentence. Add them up. Okay. So it becomes very straightforward as to what needs to be done. Which means 2x plus 16 is 30. Subtract 16 is 14. Divide by 2, you get 7. So Lisa is 7. Katie must be 23. In case they didn't ask for that, but you can check it. And you see their ages, they add up to 30. Here's another mixture problem. Coffee worth $1.05 per pound is mixed with coffee worth 85 cents per pound. To obtain 20 pounds of a mixture worth 90 cents per pound, how many pounds of each type must be mixed? We have a mixture problem. So coffee, we have type 1, type 2, mixture, cost per pound, weight, total cost. So again, it's a mixture problem. Let's see. Let's plug in what we can. So let's say the first one is 105. The second one is 85. Doesn't matter in what order you put, just be careful how you set them up. Without a doubt, we put 90 cents for the mixture. Okay, so this is no question about that. This one, if you change them, just that's fine. Now the question is, how many pounds of each type? So if you choose this one to be X, and we want 20 pounds of a mixture. First of all, the total is 20. So let's put the total here. Let's put the total here. And you choose one of them to be X. If this is X, then this one must be 20 minus X. And that's the key. The sum of these two numbers must be number 20, and it's not X minus 20. If you ever put anything, just add them up, see if it becomes 20. If you put X minus 20, they won't. And so what is the total cost here? The product of these two, 1.05 times X. What about here? 0.85 times 20 minus X. What about here? 0.9 times 20. And this last column, because we are dealing with a mixture problem, these two will add up to result in this. We distribute this one. 2 times 85 is 170, 2 decimals, you have 1 decimal becomes 17 minus 0.85x, 0.9 times 20, 2 times 9 is 18, 1 decimal, 1 0 cancel each other. Okay, so this is just basic, this is 8 concept. Now we are going to combine these two. 1.05 minus 0.85 becomes 0.2x, 0.2x. Subtract 17 from 18, you get 1. One divided by 0.2 or 10 divided by 2 is 5 pounds. So this must be 5 pounds. This must be 15 pounds. So 5 pounds of coffee number 1 and 15 pounds of coffee number 2 are supposed to be mixed.